Water is leaking from bathroom faucets on Boeing 787 Dreamliners. This is not just a cosmetic issue. Water is dripping through the floor and into the flight control computer base located directly below the lavatories. The FAA's own airworthiness directive warns that this could cause a loss of continued safe flight and landing. Yet, airlines have until December 2030 to complete the permanent fix. This means we could see 5 more years of passengers flying on aircraft where a leaking toilet might short out the very computers keeping the plane in the air. There has already been a devastating crash involving Air India Flight 171, where both engines shut down simultaneously just seconds after takeoff, resulting in the loss of 241 lives. The cockpit voice recorder captured a chilling exchange between the crew. The captain asked, "Why did you cut off?" and the first officer insisted, "I did not do so." While flight data shows the fuel cutoff switches were physically moved to the off position, both pilots apparently denied touching them in the last seconds of the doomed flight. This is Swiss flight signal. Today, we are investigating a critical design question. Could water damage from a leaking bathroom faucet cause the systems controlling those switches to malfunction? We will show you how Boeing positioned lavatories directly above flight-critical systems and why that decision creates cascading failure modes that may have bypassed traditional safety protocols. There is something about these water leaks that contradicts everything we thought we knew about how fly-by-wire aircraft are supposed to fail safely. We will come back to that point shortly. First, we need to understand where this problem actually started. In 2022, technicians during routine maintenance discovered soggy carpet tiles near the forward lavatory of a 787. They traced the water source upward through access panels and found a component called the faucet control module. Despite its simple name, this module is an electronic component that regulates water flow and temperature at the sink. An O-ring seal inside this electronic valve had failed, allowing water to leak steadily. The water did not just stay in the lavatory. It ran down wiring harnesses, poured in hidden spaces, and eventually found its way through gaps in the floor and into the electronics equipment bay directly below. This is the same bay that houses the primary flight control computers. When other airlines began inspecting their fleets, the same pattern emerged. United, American, and Delta all found evidence of water damage. As of early 2026, the US registered 787 fleet has grown significantly, with over 140 aircraft in service across major carriers like United and American, and hundreds more on order. All of these aircraft are part of a global fleet tracing water damage back to these failed faucet control modules. The 787 is not built like all aircraft. When the 747 from the 1970s had a leaking lavatory, it resulted in wet carpet and perhaps long-term aluminium corrosion. While aluminium corrosion is a serious maintenance concern, it typically takes months or years of constant exposure to compromise a structural beam. On those older mechanical aircraft, you could generally fly safely until a repair was scheduled. The 787 is different. It is a more electric aircraft where the flight controls are entirely fly-by-wire. There are no mechanical cables connecting the pilot to the flight surfaces. When a pilot moves the controls, computers process that input and send electronic signals to the actuators. Boeing positioned these vital computers and equipment bays directly beneath the lavatories to optimize space and weight. Traditional aircraft design followed a simple safety standard: keep water sources physically separated from critical electrical systems. The 787's design changed that calculation to prioritize passenger space and better weight distribution. But this created a new risk. If a faucet control module fails, we are no longer just dealing with a maintenance annoyance, we are dealing with a potential flight critical failure. Fly-by-wire aircraft are designed with multiple layers of protection, including independent computers and isolated data pathways. This redundancy is supposed to ensure that if one system fails, others take over. However, we have seen that the 787's architecture may have a vulnerability that certification testing never fully addressed. What happens when the failure occurs in the network that connects these systems? The computers are linked through shared data buses, a network architecture that allows them to cross-check each other in real time. But if water damages one node in that network, the failure can propagate. A short circuit in one area can send corrupted data to other systems. Redundancy only works if failures are independent. Water leaking from above creates correlated failures across multiple systems simultaneously. This brings us back to those fuel cutoff switches. On the 787, these switches are electronic. Moving the fuel control levers sends a signal to computers that then actuate the fuel valves. If those computers receive a signal, whether it is a valid command or a corrupted one caused by moisture telling them to shut off fuel, the engines stop immediately. Ed Pearson, a former Boeing senior manager, has been reported in the news calling for investigators to look deeper into these uncommanded cockpit actions. While the physical switches were found in the off position in the Air India wreckage, the core of the mystery remains. Why did both pilots deny moving them? Industry experts are now focusing on whether an electrical malfunction or software error could have triggered an uncommanded transition that the crew never intended, although it does leave the question of physical switches being moved still open. The largest passenger rights group in the United States, Flyers' Rights, has formally called for the immediate grounding of the entire Boeing 787 fleet. In a letter to the Transportation Secretary, the group described the lavatory leak as a dangerous design defect and argued that the FAA's timeline for repairs is not urgent enough. They warn that we cannot wait until 2030 to fix a vulnerability that could lead to another catastrophic electrical failure. The FAA maintains that its mandated hardware replacements address the known risks, but the pressure for more immediate action is mounting globally. We are now investigating 21st century aircraft with categories of failure that investigative protocols were never designed to handle. If this investigation changed how you think about aircraft systems, hit the like button. Subscribe to Swiss Flight Signal and turn on notifications. Thank you for watching.